The Sun. The Sun is the only star in the solar system and accounts for approximately 99.86% of its total mass. It is a ball of plasma, roughly 1.39 million kilometers across, held together by its own gravity and fueled by nuclear fusion in its core. Every second, it converts about 600 million tons of hydrogen into helium, releasing the energy that heats every other object in the system. Its gravity defines the orbits of everything, from the innermost planet to comets more than a light year away. Everything else described here exists because the Sun's gravity holds it in place. Terrestrial Planet. A terrestrial planet is a world made primarily of rock and metal with a solid surface. The solar system has four: Mercury, Venus, Earth, and Mars. They formed close to the Sun, where the heat of the early solar system prevented ices and light gases from condensing, leaving only high melting point materials to accumulate. Each has a metallic core, a rocky mantle, and a thin or absent atmosphere compared to the outer worlds. They are the densest planets in the system. Earth is the largest of the four, and the only one with liquid water covering most of its surface. Gas giant. A gas giant is a massive planet composed primarily of hydrogen and helium with no solid surface. Jupiter and Saturn are the two in the solar system. Jupiter alone contains more than twice the mass of every other planet combined. These worlds formed far enough from the Sun to capture enormous envelopes of gas before the young star's radiation cleared the surrounding material. Their interiors transition gradually from gas to a strange metallic form of hydrogen under crushing pressure. Both host powerful magnetic fields and extensive systems of moons and rings. A probe descending into one would find no ground, only increasing pressure until it was destroyed. Ice giant. An ice giant is a planet made largely of elements heavier than hydrogen and helium, compounds like water, methane, and ammonia, which planetary scientists refer to collectively as ices. Uranus and Neptune are the two examples. They are smaller than the gas giants but far denser, with only thin outer layers of hydrogen and helium surrounding a deep, hot, fluid interior. Methane in their atmospheres absorbs red light and gives both a blue color. Neptune radiates more heat than it receives from the Sun, driving the fastest winds measured on any planet, exceeding 2,000 kilometers per hour. Dwarf Planet. A dwarf planet orbits the Sun and is massive enough for its own gravity to pull it into a round shape, but it has not cleared other objects from its orbital path. This last requirement is what separates it from a full planet. The solar system has 5 recognized examples: Ceres in the asteroid belt, and Pluto, Eris, Makaimakai, and Haumea in the outer system. Many more candidates exist. They are typically mixtures of rock and ice, and several show evidence of subsurface oceans or past resurfacing. The category was formally created in 2006, which is when Pluto was reclassified. Moon. A moon is a natural body that orbits a planet, dwarf planet, or smaller object rather than the Sun directly. The solar system contains hundreds, ranging from irregular captured fragments a few kilometers across to worlds larger than the planet Mercury. Ganymede, orbiting Jupiter, is the largest. Some moons are geologically dead, but others are among the most active places in the system. Io is covered in erupting volcanoes, Europa and Enceladus hold liquid water oceans beneath icy shells, and Titan has rivers and lakes of liquid methane. Earth's own moon is unusually large relative to its planet and stabilizes the tilt that gives Earth stable seasons. Ring system. A ring system is a disk of countless particles of ice and rock orbiting a planet. All 4 giant planets have them, but Saturn's are by far the most extensive and reflective. The particles range from dust grains to boulders, each following its own orbit, and occasionally shepherded into sharp edges and gaps by small nearby moons. Rings are not solid and not permanent. Saturn's may be less than 100 million years old and are slowly raining down into the planet. Rings can form from the debris of a shattered moon, a captured comet, or material that never coalesced into a moon at all. Asteroid. An asteroid is a rocky or metallic body left over from the formation of the solar system. too small to be a dwarf planet. Most orbit in the main belt between Mars and Jupiter, a region where Jupiter's gravity prevented a planet from ever forming. They range from Ceres adjacent giants, hundreds of kilometers across, down to objects the size of a house. Some are solid rock, some are loose piles of rubble held together weakly by gravity, and some are nearly pure metal. Despite their numbers, they are spread across such vast distances that a spacecraft can pass through the belt with almost no risk of collision. Trojan. A Trojan is an asteroid that shares a planet's orbit, locked in position at one of two gravitationally stable points 60 degrees ahead of or behind the planet. At these points, called Lagrange points, the combined pull of the Sun and the planet holds the object in a stable pocket where it neither drifts ahead nor falls behind. Jupiter has the largest collection, with over 1 million Trojans estimated to be larger than 1 kilometer, split into two swarms, leading and trailing the planet. Mars, Neptune, and even Earth have their own Trojans. They are effectively frozen samples of the early solar system, trapped in place for billions of years. Centaur. A centaur is a small body that orbits in the unstable region between Jupiter and Neptune, crossing the paths of the giant planets. This makes their orbits chaotic and short-lived by astronomical standards, typically lasting only a few million years before a close encounter flings them elsewhere. They are thought to be objects from the Kuiper belt that were pulled inward, representing a transitional stage between distant icy bodies and the comets of the inner system. They share characteristics of both asteroids and comets. Some develop faint comas as they warm, blurring the line between the two categories. Comet. A comet is a body of ice, dust, and rock that releases gas and dust when it approaches the sun. As it warms, its frozen surface sublimates directly into vapor, forming a glowing coma and often two tails, one of gas pushed straight back by the solar wind and one of dust curving along the orbit. Most come from two distant reservoirs, the Kuiper belt beyond Neptune and the far more remote Oort cloud. Short-period comets return on predictable cycles, while long-period comets may take thousands or millions of years between visits. Each pass strips away material, so every comet is slowly disintegrating with every orbit. Kuiper belt object. A Kuiper belt object is an icy body orbiting in the broad ring beyond Neptune, extending from roughly 30 to 50 astronomical units from the Sun. This region is the source of the short-period comets and contains Pluto, Eris, and most of the known dwarf planet candidates. The objects here are remnants from the formation of the solar system that were never incorporated into a planet, preserved in deep cold for over 4 billion years. Their surfaces are rich in frozen water, methane, and nitrogen. In 2019, the New Horizons spacecraft flew past one, revealing two flattened lobes joined gently together, a pristine record of how the first bodies assembled. Scattered disk object. A scattered disk object orbits in the same distant region as the Kuiper belt, but on far more extreme, tilted, and elongated paths. These orbits were shaped by gravitational encounters with Neptune, which flung the objects outward into eccentric trajectories that can carry them 100 astronomical units from the Sun or more. Eris, more massive than Pluto, is the best known example. Because they spend most of their time in the deep cold far from the Sun and only occasionally swing closer, they are difficult to detect, and the population is likely far larger than the number so far catalogued. They are considered the primary source of long-period comet activity feeding inward. Oort cloud object. An Oort cloud object belongs to a vast spherical shell of icy bodies surrounding the entire solar system, beginning thousands of astronomical units out, and possibly extending a significant fraction of the distance to the nearest star. Unlike the flat Kuiper belt, the Oort cloud wraps the Sun in all directions. No object has ever been directly observed there. Its existence is inferred from long-period comets, which arrive from every angle in the sky, rather than from the plane of the planets. The bodies are bound so weakly to the Sun that a passing star or the tide of the galaxy itself can nudge one loose and send it falling inward. Meteoroid. A meteoroid is a fragment of rock or metal smaller than an asteroid, ranging from a grain of dust to a boulder. The solar system is filled with them, shed by comets and produced by collisions between asteroids. When one enters a planet's atmosphere and burns up from friction, the streak of light it produces is called a meteor. If any part survives to reach the ground, that surviving piece is called a meteorite. Earth sweeps up tens of thousands of tons of this material every year, most of it as dust so fine it settles unnoticed. The oldest meteorites are older than any rock on Earth's surface. Interstellar Object. An interstellar object did not form in this solar system at all. It originated around another star, was ejected into interstellar space, and is passing through on a trajectory that will never bring it back. 2 have been confirmed. The first, Oumuamua, was detected in 2017 on a path so steeply hyperbolic that it could not have been bound to the Sun, tumbling and elongated in a way no local object matches. The second, Borisov, arrived in 2019 and behaved like a comet. These are physical samples from other planetary systems, delivered to our doorstep by chance, and better detection is expected to reveal that such visitors pass through far more often than anyone realized. Thanks for watching. What would you like me to cover next? Let me know in the comments. Also, please remember to like and subscribe if you enjoyed this video.